Hi, we're back here at Devoxx 2013. I'm here with Ludo Champenois from
Hi.
the cloud team at Google. Welcome. So Ludo, you have two sessions here at Devoxx. One is on building REST APIs. We'll get to that in a moment. And the other one is about what's new in App Engine. And there's quite a few things that are new actually this year. So we'll get to that part as well. But first, APIs. Obviously, Google knows a thing or two about APIs. We publish a lot of them.
Yes.
Some are very obvious to people, like maybe the Maps API. Everybody's built at least one app with the Maps API, but we have a whole slew of them, and we all base this on one common framework, which we actually make available to developers. So do you want to tell us more about how we would go about using that?
So we have been adding APIs to our products forever, and it's a typical problem at Google. You know, Google scale. I mean, designing one API, it's easy. Two, it's easy, but once you have 1,000 of them, you want to version them. It's complicated.
Security.
You want to add security, etc. So maybe you have been using those APIs. I mean, access to Maps, access to your calendar, access to Gmail, G+, Google+, etc., etc.
Right.
So we are pretty good at delivering those APIs, and whatever client you have, you know, whether it's PHP, Python, Java, JavaScript,
yep.
Objective-C, you can have access to those APIs and make use of them in your client application. So what we have done with Cloud Endpoints is allow you as a developer to expose your business logic using the same technology and the same techniques to generate clients
right.
For your business logic and access it via RESTful web services.
So a few things that come to mind. The first one is, how do you describe the API? Is there a way to discover maybe the API?
Yes. So, well, it's in Java, okay, it's based on annotation, so it's not really JAX-RS because, I mean, JAX-RS was only limited to the Java platform, but the Cloud Endpoints technology can be also implemented in Python and soon in PHP or Go. So for Java, you have to use very simple annotations.
Right.
And from that, we generate what we call a discovery document that describes the metadata about your services. And this discovery document can be used for example, on the client JavaScript client to introspect what's going on, or to generate those client libraries.
Right. So this is something that people may be familiar with, the discovery tool, if they've been using Google APIs.
Exactly.
So we're using the same environment.
We are using the same. So if you go, I mean, yeah, those APIs are documented automatically, and you have an API Explorer tool for Google APIs as well as for your own APIs that you want to push.
So the other part is security. So how do you deal with that?
Security is also a big deal at Google, and
I think it is.
It's complicated to set up a client library to use security using OAuth, but we do it, and if you know how to do it for example, accessing your calendar via Google APIs for calendar, you are using the same mechanism that we provide for your application as well. So
right.
Obviously, your business logic can be fully secure. You can restrict for client IDs, for example. So maybe not everybody in the world can access your API because you want to restrict maybe only for Android, your Android application.
Right.
So we have all those layers of. So it's really an environment where your API is fully managed, you know.
And scales, of course.
Scales because. It runs on Google.
Maybe an interesting use of that API and the endpoints technology is something called a mobile backend starter, which is something that's built on top of that and provides a full backend solution for mobile applications.
So it might be a bit confusing, but yes, I mean the mobile starter is an example of how you can do a backend and expose it to clients. And the value of it is it's basically a generic backend that you can plug to your phone application, and your phone application can store data in the cloud using the cloud data store, which is the non-SQL data store from Google. So this cloud, it gives you a framework that you can use in your Android application to access generically resources in the cloud.
So it actually works with iOS as well, it provides notifications, it's actually much more than just a demo, but it certainly exposes the API as an endpoint API and as a RESTful set of resources to manipulate.
So you can view it both as a sample, an example of how you could write your APIs, or use it as is.
Great. So lots of good stuff here in Endpoints. Let's step back a minute here and talk about another offering in the cloud platform, which is the compute engine side of things, which is where we're back to, as opposed to the platform, fully managed environment. Platform service here, we're back to infrastructure, dealing with VMs. So you root on a VM and then you spawn those VMs. There's an API for that. Tell us a little bit more about what Compute Engine is.
So Compute Engine is basically the IaaS offering from Google. So we allow you to boot VMs in our data centers, whether it's one VM or 10,000 VMs. Very simple. You select which zone and which zone or in geography you want to.
What the image, the machine type, and off you go.
Yeah, so we have a bunch of images, and you can even add your own and store it in cloud storage and boot from it. So APIs, again, REST-based APIs, so we provide a web UI to create those VMs, or a REST access, or a command line tool to create those VMs.
Right, and then so you pay by the minute, and you have an API, so you can spawn a huge number of VMs and shut them down and only pay for what you use.
Exactly, and the pay per minute is very nice because, instead of paying, if your compute processing takes, let's say, 15 minutes, you would pay 15 minutes for Google, and not an hour. So if you pay only 15 minutes, it means that you could even shard your business processing using 4 VMs, and be done in less than 15 minutes, and pay only what you have used.
Yeah, and so of course this is infrastructure, so you're at a fairly low level where you basically SSH into the instance, and then it's like, good luck. You're on your own. You have to install.
Apache 2.
Right. You have the power of all this, network as well, not just VMs. I think there's great value in the network.
Yeah, so
of course, load balancing.
We have VM. We have persistent disk, so you can store permanently your data on disk. We have the entire networking capability, so that those VMs can communicate securely, sometimes privately between them. And we just recently introduced also a load balancer, so you can shard traffic across multiple VMs there. But it's still, you are in charge of booting those VMs and managing them, so updating them if you want to patch them, for example.
Right. But then you can run anything you want, and not just any native code, any code you have, any of that you could run. So what if I have an application that runs on App Engine, and I love the auto scaling, I love all of the fully managed aspect of App Engine, but I have this little piece of native code which I inherited from, which is highly optimized, I don't want to rewrite, it doesn't fit into the App Engine model. Can I have the best of both worlds?
We have a solution for that now. I mean, so App Engine is a platform as a service offering from Google. I mean, it has been there forever, I mean, at least since 2008. And it was running your web application in the Google data center. So we had to have security rules, because we did not want you to look around what was going on our data centers. But with the VM-based backends technology we are introducing, you can run an App Engine application inside a VM running on Compute Engine. And what it means is, first of all, it's a fully managed application, like in App Engine, but it's running in a VM where you could SSH, you could install whatever native code you want to
so I can augment
your business logic.
Any Java code to start with.
And the Java process running on those VMs is not restricted, because we don't care if
security is not at that level.
If system exec etc shut down, the machine will shut down.
Yeah.
You could not do that in App Engine. The
luckily,
traditional
yeah. So of course that's interesting, and actually that is based on one of the new features in App Engine, which is modules. So we used to have front end, back ends, and that is kind of being
Yes. So in order to enable App Engine apps running in VM-based runtimes, we introduced the notion of an application is a collection of modules.
okay.
So before you could create front-end, back-end, but now it's much easier and all those modules are versionable.
Okay.
So you have one single app sharing the same data store,
All the same
sharing the
services.
same security services, etc.
Yep.
But you can cut your business logic into modules.
Yeah.
And those modules will run in different VMs.
Like the web front end,
So
the accounting, the
so
email
you could
server.
still have one or n modules running in the traditional App Engine world.
Right.
Very fast startup and highly scalable. And some modules running in Compute Engine.
So modules have this property of being more or less scalable, or more of a front-end thing that scales up and down based on traffic,
Yes.
or more of a back-end thing.
So you just say, oh, my module will be more or less a back-end module, so I will put 10 of them, and they will always be up and running.
Right.
Or my module is a front-end, and I will let App Engine scale
The typical
to
way.
10,000 of those.
If that's what's required.
If my customer demand is that high.
Okay, so modules, and one of those modules, and this is what you were describing, can be actually running on Compute Engine,
Exactly.
and that's the VM runtime side of things, where so you can have native code, not just Java
You can
outside
have
the sandbox. You can
code.
have.
I mean, I have a demo using PDF generation using Java IWT library that you cannot use in the traditional App Engine model.
And you get access to maybe faster machines and more beefier machines
so
as well.
If you look at the VMs, I mean the processes we were using for App Engine, it's F1, F2, F4, but very small configuration, as opposed to VM runtimes where you can have 16 cores,
lots of memory. Cool.
So yeah, beefy servers. Yeah.
So in the time we have left, I want to touch on developer experience. There's been a lot of work going on into improving the tooling, and the tooling, that's of course IDEs, but that's also things like Maven. A lot of people talk about Gradle as well.
Yeah.
Do you want to walk us through the improvements?
So for example, with the introduction of modules in App Engine, we had to help the developer creating multiple modules.
Right.
And again, in Java land, the mapping was easy to use here, Enterprise Archive.
Files, yes.
EAR files. So one module would be a WAR, and then your entire application can be packaged as an EAR file. So we enable tooling for that in Maven,
okay.
in the Eclipse IDE as well, where we rewrote entirely the Eclipse plugin for App Engine, and now we are using WTP.
Okay.
So that we could rely on all the web application development and enterprise archive development capabilities in Eclipse to support our modules. And recently we are also involved in the Gradle plugin for App Engine.
Okay.
Because we see more and more customers asking for Gradle. And if you remember, I mean, the Android ecosystem moved to Gradle as a build system using the Android Studio. So having an end-to-end
story actually makes sense
for building.
So could I actually be using Android Studio to build my Android app and actually in the same IDE build the backend as well?
Yeah, this is scary, but you can build App Engine apps with Android Studio.
That's not scary.
Either you use Maven or use Gradle now, and we are adding a few hooks. For example, for endpoints.
Endpoints is supported there as well.
You will see in Android Studio endpoints menu items in the tools menu to help you generate those client libraries that you can consume in your Android application.
Cool. Last thing, I hear you can actually run App Engine on non-Google data centers. What's the deal there?
So we've been working with Red Hat.
Okay.
And Red Hat,
the makers of JBoss, I think, right?
Yeah, I mean Red Hat. If you see Red Hat, I mean they are the leaders in the Java EE platform.
Yes.
Okay? I mean they are the guys in innovating in the Java EE space, And what is interesting is they wanted to add on top of the Java EE platform the App Engine APIs.
Okay.
So basically, they wanted to take an App Engine application
Right.
as is and run it without modification on their JBoss application server.
And they did that.
Renamed Wildfly, whatever. And they did that, but I mean, as Google, we wanted to make sure that, I mean, their solution is compatible.
Right.
So we worked together on the TCK, technology compatibility kit.
Okay.
Like, everybody knows in Java land.
Available
So now-
to
so
just JBoss?
So we have now a joint project between Google and Red Hat working on this TCK. So what it means is many of our QA engineers from Google are moving
Tests and-
hundreds of tests that we had internally at Google testing
Right.
App Engine. We are moving them on
To that.
GitHub. And the JBoss guys are also contributing a lot of those tests. And it's a GitHub project. It's called App Engine.
So it's
TCK.
open source. The
It's
TCK is open source.
Apache license. And in fact, I would encourage you to contribute to it. If you see a bug in App Engine and you can reproduce it, you submit a unit test showing the bug, and
So
because we
you're
run
accepting
those
pull
tests
requests?
every day, we'll see that it's failing.
Great. So lots of new stuff in App
Yeah.
Engine, the ability to run your App Engine apps on top of Cape Dwarf is the project
So
name.
The name of the project is
on top of JBoss, and integration with Compute Engine for, then
Yeah.
the sky becomes the limit.
Yeah,
So,
so many new
lots of
things.
great things.
Yeah.
Great. Looking forward to seeing your sessions on parlays, and I'll speak to you soon, Ludo. Thank
Yeah,
you very much.
thank you.